speakers. Please welcome Steffen Herz, Director Software House E-GSH Heller Forvia.
Thank you. Good afternoon. I would like to take you to a small journey. I'm quite happy that I'm one of the last guys, because in this way I can refer to the other speaker and probably repeat some stuff, or actually make it a little bit more the journey more deep to the topics which has been touched or addressed in the last presentations. So, who has been at the ELIF 2 weeks ago? One only? Two. Not bad. You have heard about something open source software on HPCs and so on. And what I would like saying also at the ELIF, innovation is on software. And for sure, it's totally buy-in. Innovation is on software, and no doubt about this. I'm making this since, Dirk, since 94, isn't it? So we are old enough to understand this. And we see often that these things are repeating. So I would like to bring you a little bit in the context. In the context of how product development is happening in today's environment. On the beginning, when I'm talking about product development, then of course I'm talking about features. You know, we have a new idea about the feature. Actually, it's an innovation. And for us in innovation, it's bringing to the car means also always it's in connecting with hardware. So with real stuff, with a sensor or with actuators. Of course, there is enough innovation on software only where you don't need sensors and where you combine many informations, and which is cool and nice. But when we are talking about let me say product innovation and would like to bring something new to the vehicle, to the owner, then it's quite often connected to an actuator, to a sensor, to a new stuff which is connected to the outside world, or as in this way something we call it real stuff. And of course, where I'm happy now that we do not have a zoo of architecture anymore, it gets more to direction of zonal computer. And this makes our life a little bit more easier. Because then not everything is mixing up. So, and when we are talking about the feature, we bring it often to an ECU, to a single function ECU or to a multifunction ECU, and this has often the context of a classic Autosar. Why classic Autosar? Because the sensors or the zonal computer or the actuators are connected to CAN, connected to LIN, and then it's clear we need to bring in standard operating system on it. And of course, this is one motivation. And second motivation is we do not want to create another operating system in our house. So that means we said probably more than 10 years ago, we are using all Autosar Classic or all Autosar as architecture, which helped a lot and which was really at this time really a change in the way how to make software. We could exchange people, we talked the same language, and so on. It was a great thing. Second thing is, or the next thing is about features. We are talking about real-time behavior, and real-time means something which has to react in 1 millisecond, in 100 milliseconds, but not in 2 minutes or in 3. So that means when you switch on the light, then you would like that the light is switching on. When I do have now a Volvo, it's a great car, but when I'm jumping in and turning the key, which is actually not a key anymore, it's a small little button, it takes more than 30 seconds until the system is up. It's long, isn't it? So, and of course, when you start the engine, or actually you do not start the engine, you boot the system, it's fine. But when you use the direction flashlights, then you would like to have it on directly, isn't it? So that means we do have real-time demands. And related to real-time demands and related to light and whatever, you have always demands from functional safety. So that means the things we are developing, they are in almost, let me say, 80–90% are ASIL B or ASIL D, need to be qualified. So, and there you do not make, let me say, jokes about response time, about fail safe, about fail operation. It need to work on the end. So it's not something like when the display is not working, fine, you can live with it. It needs to be real. It needs to be working always in all conditions. And when I'm looking to my colleagues making high performance computer where they say, okay, 1 core, 2 cores, or even more, it's not a problem. We have to take care about processor resources because this makes money. On the end, when you have a small microcontroller, you see the bill of material, you see it turns out to money if you could use a smaller one. So therefore, you do have limited resources. And this is our, let me say, daily life, actually. What we do now in this, getting back to this journey, saying we do have a cool feature which we will bring to the automotive industry. We make a pre-development, we tested it and saying, okay, this is now something which is working, we have a sensor connected to it, and so on and so on. Then there starts a real, let me say, profound development. That means you do several V-cycle, you qualify that stuff, you bring it on reference systems. You bring it on even on more reference system because you know that in the future you will have not only one setup, you will have several setups for this. And this with all, let me say, with all consequences. On the end, we often have a bunch of reuse software, we have a system architecture behind that, and on the end we do have also a system element out of context. So fine, this all stuff takes something, when we are quick, something like in half a year, and then we are done with this feature development and we say, or the management is saying, okay, now we can go to the industrialization and we can bring it to the customer and we apply it there. So applying means, the expectation is to make it quick and easy. We don't need to change much things. It's only some small little adaptation. We are done in less than a half year and all is fine. How to go on? The customer comes. Who pays us on one hand, but on the other hand, he says, you know what, guys? I do have now a different operating system. I'm quoting operating system because on the end it's a framework and it's a special driver to it, special services to it, and so on. Okay, some of them we foreseen already. We said, okay, we make an abstraction layer around that. Don't worry, we can adapt to it. Then it comes with more security demands or with different one. Where should be the security module integrated? Is it software? Is it hardware, and so on? A different diagnostic feature. Normally we say we do have one diagnostic protocol, it's clear what to develop and what to have inside. But on the end, when you look more in deep, you see that the the philosophy, the way how the customer wants to have this diagnostic done, it's often different. And when you have bad luck, it says also, you know what, I do have this microcontroller selection choice, and what you are proposing, it's not on the list. Please change. Yeah, do something else. And with this comes a different compiler, and with this comes different, even other demands. And what is happening then? That you adapt this. And you adapt this not only once, you adapt this several times within the program, because the microcontroller is not ready for industrialization. The specification of the environment is not ready, and therefore you need to adapt that continuously. And in your, let's say, 2 years development time, you are continuously adapting it. And of course, we are doing it in the same way like you are doing. We are doing it in the generic development. Yeah, not to say, okay, we would like to have it when we have implemented that in the platform, nobody else needs to implement it. It means we do have this cycle, huh? And we try to make it quick. However, it's often a conflict about what to implement in the platform and what to make customer specific. So, and what is even worse, you do this for one customer, then the next are coming and you do it again. And what you are changing is not the application. So that means not the feature itself. The feature stays outside. It means you see that the feature is still the same stuff running. What you're changing is the boundaries around that. And nobody sees this. So that means from the end customer. Nobody sees this if the security, it has a different philosophy. Yeah, if you do have a secret shared on the overall car, or if you have a single secret or whatever. The diagnostic feature, on my Volvo, I don't see the diagnostic feature. So that means this stuff of integration and verification of the software, I think somebody said it before, I'm sure it's more than 60% what we are doing today. What we really change in the application, in the complex driver in order to improve the feature, it's often much less. And I see it also, we are using Seerene, and we compare, or we made a comparison between what we have developed as a generic solution and what is happening then in the customer project when we need to make a modification of this. Then we see often that more than 25–40% on the boundaries needs to change, and without really changing of the feature itself. So, and yeah, I think Roland Berger said, Markus, you said that, isn't it, that 2/3 of integration and verification, it's somehow, I wouldn't call it wasted, but very much lost in the area where we are making adaptation to a real customer project. And the question is, does it need to be like this? I would like to give you a more detailed example. Changing of a microcontroller. As I said before, customer wants it. Sometimes you need to make it because of risk management. There is some earthquake anywhere, and then, how is the supply chain? Do we get microcontroller in the next half year? And so on. Or you need to be flexible in your procurement, yeah, in your purchasing, and saying your purchasing department comes to you and saying, Steffen, your strategy is bad. counting on 1 or 2 microcontroller in the same area, we need to have 5 or 6 different variations. And then saying, guys, if you do have the money for it, no problem. But we don't have it. So what we need to do is we need to, it's happened that you need to change the microcontroller. And what happens with that? Of course, you need to adapt. You need to change the basic software stack, the middleware for this. You need to rethink all this stuff of startup, built-in self-test, security. Probably you can talk for the next half an hour what you need to take care of when you change it. And when we are talking about making software independent from hardware, and then I'm looking to this example, I'm looking to the MCAL, actually MCAL, or the microcontroller abstraction layer, which we do have on the AUTOSAR layer. Yeah, then I'm thinking we are dinosaurier. We are, this is old stuff. You need to, it's unbelievable what you need to change when you are going to a different microcontroller. And we do have experts, you know, dedicated to this. And when they are saying now we are getting this one, we have to investigate there and there and there, and the list gets longer and longer, then you, yeah, the jokes are over. Yeah? You need to reconfigure the entire software. And reconfiguration, I was happy some years ago, or actually more than years ago, that we say we come away from the topic of coding software, we are more reconfiguring the software. But when you are looking today's in the possibility of configuring software, you need to have a special training only for configuring the communication stack. Because there are so many variation in that, you have so many possibilities to make it, and it's not something like easy to make. So that means configuring, it's our often it's our day-to-day business. And when you I'm looking, as I said before, we are using also Seerene in order to see what happened on the code base, that all the files which are generated because of different reconfiguration, they are continuously changed. And this is crazy. So, coming to topic, redo all safety analysis. Who of you are developing ASIL-D systems? So, then probably you know what means making a safety case with ASIL-D. Yeah, this is, and when you have to say, I have to make it new now because there are new requirements coming, new assumptions of use are coming. You are thinking on beginning, yeah, I need to revisit only some things. But you will quickly recognize revisiting is not enough. You need to dig into it. And when you make there a mistake, it could have on the end a big impact to the effort later. So, and what is happening now, that the microcontroller supplier is giving you assumption of use, the compiler giving you assumption of use, the basic software supplier gives you an assumption of use for the all new stuff. And once I have added all the stuff on a small system, we had something like 800 new requirements. And now making the bridge a little bit to generative AI. What I hope and what we tested already, it doesn't function really, or not yet, I would say, or I hope, to compare specification. Compare specification, the evolution of it, and saying, okay, we have their version 1, now comes version 1.1, 1.2. This is somehow possible, but when you compare a specification from Infineon to Renesas, to NXP, it's not that easy. So what you do is then that you have engineers and looking to it in detail. So, and again, these things are not stable. So that means they are updating while you are bringing the software on the street. And this is really a big hurdle. And I like the idea of or not the idea of a flow. Yeah, saying you need to make always the cycle. Yeah, you need to be quick in that. You need to make it transparent, because often when I'm discussing with my managers, they are saying, I do not understand why this takes so long. Yeah, what are you doing? The feature is ready. You need just to bring it into the car. That's all. Yeah, and you have done it already with GM, with whoever. Yeah, and now you take the next customer. So what? Why you need that long? It's not understandable. Yeah, or from this perspective. So what is one part of the solution? And we discussed it already, or we showed it already in some presentation before. We do have many coalition. We do have many consortia, yeah, Covesa, Eclipse, SDV Foundation. We do have Autosa. Yeah? We do have many of these groups, and they are all talking about standardization. I would like, and this is basically the call I would have to us and to our automotive industry, is that Tier 2, Tier 1 OEMs, these groups are sitting together and saying, guys, we do make one or two solutions. We do have a framework which is quick enough, which is flexible enough on one hand, but which gives us also a kind of stability. And Dirk is telling me since I'm here that, Steffen, Google will make it. They will bring it, and then you get rid of all this different stuff. Actually, I do not know. And but what I'm seeing right now is that we are not coming to this in the next years. That we are still having different formats, that the tools are different, that the processes how to come to this are different. The interfaces between the documents are different. Sometimes we are getting a specification in PDFs. What to do with it? It's crazy. And we need, and other industries are much more quicker on this. Yeah, they are standardizing, for example, the open source. They have two formats in order to define what is inside the software. We are not able. And when I'm looking, I'm personally working much also with the Autosar consortium. There is now the open strategy, which is fine, but I'm thinking on the end it's by far too slow, and it's too slow and too much as a closed shop and not really something to open. And therefore, my wish is that we have an automotive standard which goes on the complete supply chain. That means from the microcontroller, from software vendor until the final guys who are making software services, to have one, or let me say in framework which helps to deal with the different variants which should not be there. That's all.
Thank you very much, Steffen Herz.